So in the previous video, we talked about the literal definition of specific heat. And in this video, we're going to talk a little bit about how that property of a material affects how it behaves. All right. And in doing this, I like to use a little bit of an analogy to how things behave. I like to make an analogy to the difference between these two different springs. All right. So one of these springs is made of a relatively thin wire, and one of them is made up of a lot thicker wire. And if you've ever played with springs before, you realize that in general, the thinner the wire is, the easier it is to compress it. Right? So this one with the thin wire, I can squeeze it really easily, but this thick one right here, I can basically try to squeeze it with all my might, and I still can't get it to compress all the way. All right. So what we're going to do is we're going to make a comparison. All right. We are going to compare temperature to the length of the spring. All right. So why are we making that comparison? All right. If you think about the spring right here, what is the only thing that we can, with complete certainty, measure about it? All right. Is it the amount of energy that it has in it, or the length? All right. And the thing that we can always measure about it is its length. All right. If I do that, you can measure the length. And if I do that right there, I can measure its length. But if I were to say, how much energy does that spring have? We don't really have a way of measuring it, directly. All right, we would have to do some experiments in order to measure that. All right, so in the same way we can do that, if I were to say, what do we know about this oil right here? Do we know how much heat it has? All right, well, that would actually take some calculations. The one thing that we do know directly about it is its temperature. If I put a thermometer down in this, I can measure that right now. So when you think of temperature, think about the length of the spring. All right. So as far as heat is concerned, what I want you to think about is the amount of squeeze that you put in, either the amount of squeeze that you put into the spring or the amount of pull that you put into the spring. All right. And think of that just like you would heat energy. In the same way that I can cause the length of this spring to change by putting in some squeezing energy, I can cause the temperature of this liquid right here to change by putting in a little bit of heat energy. All right. So again, think of the length of the spring kind of like the temperature of the material. All right. When you're thinking about heat energy, compare that to the amount of squeeze that you're putting into the spring. All right. So here's the thing. What does this have to do with specific heat? All right. And I think that most people understand how the difference between these two different springs. All right. These springs can either be, for example, this one right here, it can either be short or it can be long. All right. It can either have, like right now, I'm not putting any energy into this, but this spring right here has got a decent amount of energy in it. All right. So the amount of energy can change, the length of the spring can change. What's one property about this spring that always stays the same? And that is the thickness of the wire. All right. So let's think about this spring right here. I can change its length and I can change the amount of energy in it. All right. But one thing that's always true about this is the thickness of its wire. All right. Notice that the thicknesses of these two wires is different. All right. But for this particular spring, that property is always the same. And for this particular spring, that property is always the same, but they're not equal to each other. All right. And one thing that you probably realize about springs is that if something, when something has a really thick wire, all right, you can put a lot of energy into it and it changes the length by a very small amount. If I put that same amount of energy into the other spring, all right, notice that its length changes by a lot larger amount. All right, so the same amount of energy put into this spring causes a very large difference in its length. All right, whereas I do it here, if I put in that same amount of energy, it's a very small change in its length. All right, drawing that analogy to different liquids. All right, what I want you to do is to think about water as acting like this thick spring. All right, let's think about what happens when I put in energy into this thick spring. I can put in energy, but its length doesn't change by that much. All right, if I take this little bit of water right here, and I have my candle, and I put some heat energy into that water, what would we expect to happen to its temperature? All right, so water has a high specific heat. All right, that means that a lot of energy doesn't really cause a big change in it. All right, a lot of heat energy causes some temperature change, but not a lot. All right, when you think of a material like oil, something that's got a low specific heat, think of the thin spring. All right, if I put energy into it, notice that its length changes by a lot. All right, so if I take the oil and I heat that, all right, the same amount of heat, if I give it the same amount of heat that I gave that water, its temperature changes by a lot more. All right, so if you just remember this analogy to think about, when you think about water, think about what happens with the thick spring. All right, when you think about oil, think about what happens with the thin spring. All right, so one thing I want to point out is that this relationship goes both ways. All right, so far we've been talking about just putting heat into something. All right, but realize we can also cool things down. All right, and we do that by taking heat away. All right, so if I want to put heat into this water, I would do something like hold it over a candle. But what would happen? What would be a way to take heat away from this water? I put it in the freezer, all right, or I put it in ice water. And that's gonna, if I put it in ice water surrounded with something that's colder, heat is gonna travel out of this, causing the temperature of this to decrease. All right, so think about the way this, so this is the thin spring right here. And this same spring, the same types of springs that if you put a certain amount of energy, if you can cause it to shrink by a lot, are the exact same types of things that if you pull on it, you can cause their length to change, to get longer by a lot. All right. So remember the thicker spring right here. If I put the same amount of squeeze into it, it's going to get smaller, but only by a little bit. All right. But if I pull on it, I can put in, I can pull with all my might, and I can barely get it to get any longer. So water acts like this right here. It takes a lot of energy for its temperature to go up by a little bit, but you have to take a lot of energy away from it for its temperature to go down. All right. Whereas oil, you give it a little bit of heat, and its temperature is going to shoot up. All right. You put it in the freezer, you take some heat away, its temperature is going to shoot way down. So this part right here just sums up what we've been talking about. The thin spring, if I squeeze it by a certain amount, you get a large length change. The thicker spring, the same amount of squeeze just causes a little bit of length change. All right. Oil is like the thin spring. 1 unit worth of heat causes a large change in its temperature. All right. And when I'm using oil, I'm using that as an example of a substance that has a low specific heat. And CP, that is the mathematical way of writing specific heat. That's the variable that's used. All right. And water, that's something with a high specific heat, is something that if you gave it the exact same amount of heat, its temperature would change by less. All right. The same thing would apply to the temperature going down. If you take away 1 unit worth of heat from the oil, its temperature would go down by a lot. If you take away 1 unit of heat from the water, its temperature would go down, but not quite as much for the oil. All right. So there's another property thing about specific heat that you can use the springs to describe. All right, and that is to think about this. All right, if I took this thin spring right here and I compressed it all the way. All right, well, when I let it go, all right, and actually for this, instead of compressing it, I'm going to bend it. All right, so I can take this thin spring right here and I'm going to bend it sideways like this. All right, so this spring right here now has some energy in it. All right, but I think one thing you realize is that I can release that energy by just letting it go. All right, so what I want you to think about is when this thing has been bent sideways, how much energy is given off when I let it go back? All right, so it gives off some, but not an incredible amount. Compare that to this thick spring right here, which is remember, think water when you're thinking about this thick spring. All right, if I get this to the exact same position I had the thinner spring, all right, I bent it 90 degrees, and then I let that go, it gives off a tremendously higher amount of energy. All right, think about which one of these springs you would rather have near you. This thin spring bent like that, where when I let it go, it gives a little tap, all right, or this thick spring that I really have to bend it a lot to get it into that position, but when it goes back, it gives off a tremendous amount of energy. All right, well, let's make the analogy. So remember, think of the position of the spring just like the length. All right, think of this as like water at 100 degrees Celsius, and think of this as oil at 100 degrees Celsius. All right, well, if you had, so water, the oil and the water, even though they start at the same temperature, when you leave them out, all right, if you put them on a table, that 100 degree substance would want to cool off to room temperature. And in order to cool off to room temperature, they have to release heat. All right, so the question is, would they release, if this is at 100 degrees and this is at 100 degrees, would they release the same amount of heat when they cool off? And the answer is no. All right, materials that have low specific heats, when they change their temperature, all right, 100 degrees to room temperature, they give off relatively small amounts of heat. Remember, think of the thin spring. When it goes from this position to that position, it gives off relatively small amounts of energy. You're not going to hurt yourself if you get hit by that spring right there. All right, but higher specific heats, when they undergo the same change, give off lots more energy. All right, so what does this mean, practically about a material? All right, let's pretend that like you've got both of these at 100 degrees Celsius. All right, you put both of these down into boiling water, and they're both at 100 degrees Celsius. Which would do a better job of keeping you warm? All right, let's pretend that I take this and I put it in my shirt, and I'm going to let some of that heat eventually, come out of this and warm me up. Which would do a better job of warming me up? All right. Well, the thing is, the 100 degree water would do a better job, and that's because it's a material that's got a high specific heat. In order for its temperature to change, it has to give off heat. All right. So remember that there's this interplay between things, just like the springs. If the length changes, the amount of energy changes. All right. You can't change the length without changing the amount of energy. Think about the same thing with liquids or any material. All right. You can't change the amount of the temperature of it without changing the amount of heat in it. All right. So that leads into the math, the equation that we talked about in class, Q equals mCp delta T. And hopefully you will be able to use that to solve problems with this topic.